Hey guys, welcome back to the second part of 6.1. And we're just going to be covering linear velocity today. So, um, linear velocity is the rate of change of displacement, so distance moved per unit of time. And so, well, if we remember my example of the death carousel, or the carousel of death, whatever I said, um, we said that a person on the inside and a person on the outside would have the same angular velocity, right? The angle per second is changing at the same rate for both of you. However, your linear velocity, right? So if you're on a circle, right, and you're spinning around, your velocity is straight to where you are. And when you think of linear velocity, you can basically just think of like speed, like your actual speed. Um, and that is going to be more the farther you are out on that circle, right? Because then you have more distance to cover going around in the same amount of time as someone does on the middle. So um, we get this equation v equals r times theta over t, where v is that linear velocity, makes sense, v velocity. And it's the same thing, we have theta over t, right? Um, and r is the radius that you are out on the circle. And so this is kind of important. If we notice that theta over t, that's the same thing as that omega that we had, our angular velocity. So we have v equals r omega, which is our big one. So just getting right into it, determine the linear velocity of a point rotating at an angular velocity of 17 pi radians per second at a distance of 5 centimeters from the center of the rotating object round to the nearest tenth. And this is as simple as v equals r omega, and it gives us that r is 5 centimeters, and that omega was 17 pi, and it's already in radians per second, so it's really nice for us. When you're in, radians per second, minute, hour, that is an angular velocity. And so we just type that into our calculator. 5 times 17 times pi, we get 200. That's not 200. 267 .0 is actually rounded to the nearest tenth. So, and that's all it is. And this will actually be in uh, centimeters per second. So the next one, determine the linear velocity of you and your friend on the carousel of death. And so your friend, if we remember, well, first of all, our linear velocity, which we found earlier, which I think is gone, we'll have to find really quick. Our omega was theta over t. So omega for this one, we have 13 revolutions per second. So we're going to need to do 13 times 2 pi all over t. Or it's already given to us, right? So we have 13 revolutions per second, and we want to go 2 pi radians per 1 revolution. Revolutions cancel, and we're left with radians per second, which is, or we could just write 26 pi. So in the other one, we wrote out a decimal, but we could just use 26 pi for this one. So, so we just found that omega, our angular velocity, is 26 pi. And that was in radians per second. And so if I'm looking for your friends, we know that v equals r times omega. And if we go back to that problem that we had, where is it at? This one. Your friend is 9 feet away. So 9 times 26 pi. That is going to leave us with 1,551.9, and that was in feet per second if you go and read the problem again. And then same thing, V equals the radius times omega, and V equals, and then I think it said you were 35 feet away. Yeah, 35 feet away. So 35, and then your guys' omega is the same, 26 pi. So it should be 2,858.8 feet per second, right? Yep. So very, very insanely fast, which is why you don't want to be on that carousel of death, right? That's incredibly fast. Now, so here we're going to have linear velocity. Again, the tires on a race car have a diameter of 30 inches, so that means the radius would be 15 inches, right? If the tires are turning at a rate of 2,000 revolutions per minute, determine the race car speed. So let's break this down. We have V equals, let's do our R first, right? So our radius, and it says it wants it in miles per hour. Our radius is 30 inches. So we have 30 inches, and I'm just going to put over on, our radius is actually 15, right? So 15 inches, and then we're going to want to multiply that by, there's 12 inches, right? Because I want to get rid of inches in 1 foot. And then there are 5,280 feet in 1 mile. So that puts us in miles, which we want, right? We want in miles per hour because inches are going to cancel and feet are going to cancel, and we're going to be left with miles. And that is our radius, right? That's going to convert our radius to miles. And now we need to times it by our velocity. And our velocity, let's do this, we have 2,000 revolutions per minute per 1 minute. And we are going to want to change that to hour, right? So then there is 60, we want minutes on top, so if the minutes cancel, minutes per 1 hour. Right, so then minutes, and then also we're in revolutions, right? But we need to be in radians, so we're going to times that by 2 pi radians, and then that's going to be this is our angular velocity, right? And assuming I've done that all right, what's going to be left, right? 2 pi per 1 revolution. What's going to be left is we have miles per hour, and that's just something that we need to put in the calculator. 15 times 1 times 2,000 times 60 times 2 times pi. And that's a really big number, but then it needs to get divided by, and I'm going to put in parentheses 12 times 5,280, and the rest is 1. So we get that the velocity is 178, and then it wanted, if it wanted no decimals, then it would just be 178 miles per hour. And that is going to wrap up 6.2.